Welcome everyone to the third video on the course of machine learning and software engineering. So today we will see the life cycle of a machine learning project. That is to say, we will study the different steps that compose the design and the life of a machine learning project. So I think it's really quite important in software engineering to know how you can conduce a machine learning project and to know how you structure a project like this. So it will be quite applied, but we will also try to gather some insight on how to conduce such a thing from the theory. But it will be mainly practical. So I think it will be, this course will be hopefully very useful for you if you want to apply machine learning in the context of academia or in the context of industry. Okay, so let's start with the life cycle of a machine learning project. So here you can see that we have different steps of machine learning projects that follow each other and that are related by arrows. Let's see first that we have two big phases: the model design one on the upper part and the operational phase on the lower one. The model design part is basically the building iterations of a model, and the operational one is deploying and monitoring the model. So you can see that we first start with a business problem. It can be an academia problem too. We then define a goal, and then we continue to data collection and preparation, feature engineering, model building, model evaluation. And then this is the first part of the model design. So this is to build a model. And then we go to the operational phase by deploying the model, serving it, monitoring its deployment, and monitoring the model, how it performs, and then doing some model maintenance if it's needed. So you can see that the blue squared corresponds to machine learning engineering. But we will also cover the definition of goals because it can be useful for you, because in some small companies you also have to do that. And yeah, so we will go into the detail of each part of the model design part, and the operational phase one will be kept for future course. We have a business problem or an academia problem, but basically we have an issue that we want to tackle. So in this part, this is really the beginning. So it's before doing any code, before doing any data gathering, before looking at what data is available, you really want to define your problem and to know if you can use machine learning in this case. Okay, so let's start with that. When to use machine learning? So I'm quoting the book that I already told you about. So you can consider using machine learning in the following situations. So if your problem is too complex for coding, so it means that you cannot really do some traditional software development to solve a problem. So if you remember about the first videos that we saw together, we saw for example, the classification of cats and dogs images. So it's really hard to come up with rules if you think of traditional software development to detect if an image is a cat or an image is a dog. You can maybe compute some properties of the images, like the dominant colors, the percentage of some colors, and if you think that some colors are more associated to cats than dogs, and things like that. But it's really hard to come up with good solutions for traditional software development. and it's hard, and also you don't really know, like maybe you analyze some color and you will come up with a solution, but is it a good solution? Okay, so you can use machine learning if the problem is too complex for traditional software development, for coding manually. Also, if the problem is constantly changing, machine learning can be good, because you can imagine that if you have a task and if the solution is always changing, if you do a manual one, you may lose a lot of time coming up with new rules, to adapt manually your software, to develop to change your code, to refactor your code, to modify it, to adapt to the problem that is constantly changing. So if the problem is changing constantly, if the solution have to be adaptive, it may be useful to use machine learning, because it will be easier to train a new model and that will be adapted to new data than it is to redo to redo code and to come up with new rules, to implement them and to deploy them. Also, if you have a perceptive problem, machine learning can be considered and to use. So, for example, if you have images, speech, video recognition, so if you want to do image recognition, speech recognition, and video recognition, then machine learning can be useful. So this is called a perceptive problem. Because it's basically doing some perception like humans do. So if you want to do that with computers, generally machine learning is a good solution. So it may be, so this is, for example, the example of cats and dogs again. It goes into this category too. Also, if you have an unsteady phenomenon. So let's say, for example, that if you want to study some physics, the gravity, how gravity is influencing an object that is falling on Earth, well, you don't need machine learning, because this is a well-studied phenomenon. You know the physical equation, so you don't really need machine learning. But let's say that you are studying another phenomenon in physics that is not well studied. You don't have a defined formula on how to compute the thing that you're interested in. It may be interesting to consider using machine learning in that case. Also, if your problem has a simple objective that you can quantify, so for example, if you have if you can answer a question by yes or no, you can make a decision by yes or no, or if you can formulate your problem into having a target that is a single number. In that case, so you can define your problem in an easy way, in a simple objective way, and in that case, machine learning can be considered to be used. Also, you can also consider using machine learning in other situations where it is cost effective. So in some case, you can solve a task two ways: the traditional way in software engineering, so like coding traditionally, and using machine learning. And maybe you can both are adapted in that case, but here what you have to think is cost. Because in machine learning, you have three main costs. You have the cost of building the model, you have the cost of the infrastructure to serve the model, and the model maintenance. So the cost of building the model is basically, as we have so quickly on the life cycle, it's like gathering the data, choosing a model, training it, etc. So it can be costly in terms of time for you as a developer, but also costly in terms of resources, because training some big model can be costly in terms of computing power, computing in general. So also another cost is infrastructure. because when you want to deploy your model, you have to serve it, you have to have an infrastructure to do it. So if it's very costly to do each prediction, if it's costly in terms of resources, if you need a lot of computation to do, for example, to predict if an image is a cat or a dog, well, you have to consider this cost too, because it will cost you a lot of resources. And also the last one is model maintenance that you have to consider. So once you have developed your new model and once you have deployed it, you have to maintain it and to monitor it to know if it's still performing the same way as it was at the beginning and as it was intended and the data that it was trained on. So you have to consider this free cost. Okay, so just as a small precision, here we are considering using machine learning in those situations, but it doesn't mean that if you can tick one of the box, if you are in one of the situations, you have to use machine learning. So, for example, if you have a perceptive problem, but it's a very easy thing to do, you may not need machine learning at all, and you can just come up with traditional software development and come up with some rules defined by hand. So you can consider using it in that way. So this is kind of a joke. It's a famous meme that you may know, but the idea here is that with machine learning everywhere, the idea that I wanted to say to you is that if you go to the industry or if you go to academia, sometimes people just want to apply machine learning just for the idea of applying machine learning because it's trendy. But it's really important to know when to not use machine learning, because even if machine learning is trendy, sometimes it's not good to apply it in some solutions. So what I mean is that sometimes in the business people will tell you, oh yeah, we have to use machine learning, but they don't know if it's really a good solution for your problem. So it's important to know from the beginning if machine learning is interesting. And sometimes you may have, as a machine learning expert, in some way you have to tell to the expert of your domain if machine learning is adapted or not. So when to not use machine learning? So it's probably better to not use machine learning when, for example, getting the right data, getting good data is too complex or impossible. So in that case, if you cannot get data, you cannot learn from it. And if you can only get bad data or data that doesn't really correspond to the task that you are, it will be difficult or impossible to learn. So for example, if you have no relation between the features and the labels, so remember that in supervised learning, in order to learn, you have to be able to have some examples that have both label and features. If you have just a bunch of labels and a bunch of features, but you have no way to make the link between the two, you cannot do supervised learning. You will not be able to learn relation between features and label if you don't have this relation in the data. So for example, if we consider the price prediction of the houses, so we want to predict the price of housing, in that case, if we have, for example, the prices that came from notary sources, but we don't have associated to the houses its characteristic, its feature, and we have characteristic of some other houses that came from, for example, ads or some other sources of data. If we are not able to match the two to know for what is the price and what is the features, the characteristic of the house, it will be impossible to learn and to predict the price housing. Also, it will be difficult to get the right data if the phenomenon, if you have a lot of outcomes. So if your label is very large, if you have many labels, and you cannot get enough example for each outcome. So, for example, if you want to predict animals, photos of animals, so if you can have cats and dogs, and also every type of species and subspecies of cats and dogs, and other animal like turtle and all of the other animals that you can think of. If you cannot get enough data, so for example, if you have only 10 images of each subspecies or each species, it will be very difficult to learn something. So generally, you have to be able to get enough data for each label, for each outcome that you have. Okay, so another case is that when you know how to solve a problem using traditional software development at a lower cost. We already talked about this in the last slide, and it was sometimes you can have two solutions: a traditional software development one and machine learning. Remember that we have saw that there is three main costs in machine learning, and if the sum of those costs are a lot higher, you expect that these are a lot higher than traditional software development, maybe it's better to just go with traditional code and to solve it using a rule-based solution, for example. So one of those cases is that, for example, if you can fill an exhaustive lookup table manually by hand by providing the expected value, the expected output, for each input, for any input. So if you can fill such lookup table by hand, it's really not necessarily to use machine learning. It will be a lot more complicated to use. So maybe people in the sales department of your company, or maybe in academia, it will be better and will be easier to publish if you say that you use some crazy complicated machine learning model and such thing. But if you can find such an easy solution, it's a lot better to come up with them, because it will be less costly, easier to maintain, and easier to serve too. You will gain a lot of time with that. Also, if you have a complicated thing, a complicated solution. If you have to come up quickly with a solution, it may be better to just come with the traditional software development one. That maybe the solution may not be perfect, but at least you will have the first solution, and you can then iterate and see if machine learning can be another solution in the second step once you have more time. Okay, another case when to not use machine learning, if it's every decision made by the system have to be explainable. Machine learning, you can think a model in machine learning, generally, you can think it as a black box. So you give some input and you have some output. But it's really hard to know how to explain the decision that was made by machine learning, because machine learning is kind of an abstraction of learning, of decision making. But sometimes it's really, and most of the time, most of the model, it's really difficult for humans to understand how the decision was made by the model. So one counterexample of that is decision tree. Decision tree, you can interpret it if it's small enough to be able to interpret it, because, well, you have some binary condition, and you can look at what are these conditions and what are the conditions that were evaluated in order to predict your example. So really, if you are in the system that impose some explainability for each decision, for every decision to be explainable, then machine learning may not be necessarily the best choice. So it can be, for example, GDPR requirements. Sometimes with GDPR, you have to be able to give an explanation. It can also be if the change of the decision in a similar situation, you have to be explained if it changes. So what I mean by that is that you gave an example at time t, you have it, and then you at another time you give the same example, and you have another outcome, another decision that is made by the system. So in that case, if you have to provide an explanation on why the second time the solution, the output was different, maybe machine learning is not the best thing because it will be hard to explain it. So this can be the case if, for example, you deployed a first model and then you made a prediction with that. You deployed a second model, you retrained your model on new data, and then you have a second model, and the second model make a different decision than the first one. In that case, it will be difficult to explain why the decision was different. Another situation when it's not necessarily the best thing to use machine learning, if it's the cost of an error made by the system is too high. So if for example, you will lose a crazy amount of money if your decision is bad, then if the decision is not good, if you make an error, then it may be machine learning may not be such a good choice. So that's why, for example, it's so hard currently to have autonomous cars, self-driving cars are really hard to design because you need such a good accuracy, such a low error rate that it's really difficult to come up with a very good model that is safe because you don't want your car to drive on people and to kill people. So and the cost can be really high in that case. So it can be very difficult to use machine learning if the cost of an error by your system is high. Okay, so we have seen the business problem. We have seen when we have to use machine learning and when not to use machine learning. Let's now review the goal definition. So you have a problem, hopefully in business or in academia, you have a problem. You see if you want to use machine learning or not. If you want to use machine learning, then we continue in the life cycle of the machine learning project. So here the goal is to define the goal. So here what I advise you to define a goal is to really write down the different elements of your problems. So if it's kind of a field box, a text with blanks, you have to answer different questions. And if you really write it in paper or in a computer, like it will really, I think it will really help you to define clearly at an early stage the different elements of your problem. And I think it's especially important to do it at an early stage because it will allow you to have a better idea and a clearer idea about what is your problem and how you can solve it. Because if you define the different element of your problem, then you will have a better idea of what type of data you need. So the first question to ask is, what is my objective? What is my general objective? So we will see some example in the next slide. But here the idea is that the objective is a quite general one. Then you have another one, which is more specific, is what is my task? So the objective is a very general one. The task is more specific. Then you have inside my task that I want to solve, what is an example? What is the thing that I want to predict, the thing that I want to study, the main element. Then the other question is, what is the expected output? So for each example, what output will be useful, what my system will use as an output. Once you have defined that, you may one important question to ask is what are the acceptable behaviors and what are the unacceptable behaviors? So here you can think of performance. It may be the more intuitive part, like I want my performance of my task to be at least of some amount. So for example, it can be that your system is accurate at 90%, at least 90%, and as an acceptable behavior, and an unacceptable behavior is that it will be less than, let's say, 80%. So, but think also in terms of security, so computer security, in terms of discrimination, privacy, ethical issues. I think it's especially important to think about this at a very early stage in order for you to design the whole project, the whole life cycle of your machine learning with that in mind. Because if you come up with at the end of your model design and you just discover that you have some issues, you may lose sometimes, but it can be worse if you discover some problems at a later stage. So maybe you were familiar, but some years ago, for example, the automatic image recognition algorithm in Google classified a photo of a black woman as a gorilla. Or black man, I don't remember, but it was a someone black, and the machine learning classified it as a gorilla. So it was really problematic because here you have a clear case of discrimination. So it can be really problematic if you discover this type of problems at a late stage. So if the model is already deployed, because the bad behaviors, the unacceptable behaviors are already happening. So let's develop quickly some points. So in terms of security, you have to think what is the consequences of if I have an attacker facing my machine learning model. So think of spammers, for example. If you train a spamming spam filter, maybe you have an attacker that will try to change words by synonym in order to evade your spam filter, or maybe he will misspell voluntarily some words so that your spam filter doesn't recognize them. So, for example, if you have, I don't know, Viagra, it will replace the A by a 1 and the A by an arrow, by other characters. So this can be the type of examples that you have to, the type of unacceptable behavior that you have to think of. Also discrimination, I already gave you the example. Another famous example was Equifax in the US. The Equifax was basically sorry, not Equifax, Compass. The company was called Compass. Equifax is an example of data breach, and this is not related. This is Compass. So here, Compass had a model that were predicting if, when you have a jury trial, if the person that was accused of something, some felony, was what was the probability of him being convinced again doing some another crime in the future, so to be again in front of a judge. So this was used by the judge as a way to assess if someone was if it was probably going to do the same bad behavior, same illegal behavior. So the problem is that, so it was used in the jury trial. The problem is that it was discovered that it was highly discriminative against black people. So if you have a white person and a black person, the decision was not the same by the probability of being of doing the same crime again was not the same. So here you have another case of discrimination that was embedded into the machine learning model. So I really put a strong emphasis on the fact that you have to consider from the beginning what can be the unacceptable behavior in terms of discrimination. Also, another example is in terms of privacy. So you have to think of privacy. What happened if my model is breached? Can people recover some training data inside my model? So this is it was shown that you can approximately recover some training data. So for example, you have a machine learning model that was used, that was trained to recognize faces, and it was shown that you can more or less recover some photos of that were used to train the model from the trained model. So just you having the model that is trained, you can sometimes more or less approximately recover some examples that were inside the training data. So here you can see that it can be a problem, especially for medical application if you apply it into the medical domain, because you want to ensure that the data that you have will not be leaked if you release your model, for example. You also have to think about the sensitivity of the data that you will have. If the data are very sensitive, you have to to be extra careful and to put a lot of things, a lot of process in order to be sure that the data will be treated by respecting privacy. So also another thing is ethical issues. So if you are tackling, for example, some problem, I told you about the judicial system, it can be pretty problematic if you handle if the judge is influenced by a black box model that is not able to explain. So I don't say that it's bad in itself that the jury is using some algorithm and some machine learning to make a decision, but it's not good neither. It's like you really have to think about what are the ethical issues associated with it, and it's really not evident. It's really not easy to answer this question. So think in mind from the beginning what are the potential ethical issues that you can have by applying machine learning in your case. Okay, so coming back to the problem, now that you have written down the element of what are the acceptable behavior and the not acceptable behavior, you may want to know how you can measure each of them. So what are the what are the metrics that you can have to measure each acceptable or unacceptable behavior? So if you are thinking of performance, you can take the accuracy. For example, you can take some performance metric and say that if your accuracy is higher than 95%, it's good. It's an acceptable behavior. It's lower than some threshold, it's bad. And you can think of, discrimination also. You have different, inside the academia, inside the published paper, you have different methods that exist to assess if your model is being discriminative against some people. You have also some metrics and some methods to ensure privacy and this type of things. And also security. And lastly, once you did all of that, you want to ask your question, do I have available data? Or if not, can I build a dataset? I said lastly because it really have to be the last points that you ask you. And because generally people rush everything and just go to find a dataset to see what can they do. But generally, it's really better to think the other way around and to think, what is my task? What is my general objective? Inside what is my task that I want to achieve, and then to go step by step in the order that I showed you, and not to rush the other way around and to come from the bottom to the top, from the last to the beginning. Really, I advise you to do it that way. So once you have done that, you can ask, do I have available data, or can I build a data set? So we will see that into more detail. But the important thing here is that if I am able to build a data set, to collect some data. So let's take an example here. We will take the example of the spam filtering. So what is the objective in this case? Well, I'm an email provider, and I want to offer the best services possible to my user. So this is the general objective. You see that it's very general. It's the objective of my project, my companies, or my project in general. The task here is to automatically detect spam in order to provide this service to the user, so that they are not annoyed by constant spamming. An example here in this case, in this task, is an email. So what will come in the machine learning model is an email. The output has to be if it's a spam or if it's a ham, if it's not a spam. An acceptable behavior, as I can say that if my model classify most of the spam, it's good. So I can measure this classifying most of the spam by the fact that the probability of detecting a spam is at least 79%. So this is called sensitivity or recall, and this is equal to the number of spam that is detected by my system among the ones that are spam, divided by the number of spams. So it's basically the percentage of real spam, of spam email, that is detected by my system. So you will see a lot in binary classification, the sensitivity or recall. This is one metric. So what are the type of unacceptable behaviors that we can find? Well, for first, in terms of performance, malleable should be, we want our filter to classify only spam, to classify a very small amount of ham, so something that is not spam, as a spam. So we want to not make too much mistake in that specific type of mistake. So we can measure that unacceptable behavior by the specificity. The specificity is a matrix. It's also called the true negative rate, and it's correspond to the amount of ham that is classified as ham. So here it can be at least 95%, so that we don't put too much ham into the spam filter, into the spam folder, for example. So you can see that you can have, an important point here is that you can have different level of acceptable and unacceptable behavior. Because here you have the specificity of 95% and sensitivity of 75%. So you can see that here, in that case, it's more harmful. We can think that it's more harmful to classify a real email, a ham, as a spam, because probably the person will not see it, than it is to classify a spam as a ham. So one type of error is more problematic, is more grave, is more problematic than the other. And we can embed this constraint into some differentiated metrics. The two type of problem can be measured by different levels, different thresholds. Another type of unacceptable behaviors can be security. In terms of security, a spammer should not be able to find easy way to fool the spam filter. So, for example, if the spammer replace some characters that are very similar, or some normal Occidental character by some characters that are looking exactly the same but that are in another alphabet, the spam filter should not be fooled by that. Or maybe it's also it would be good if it would be good if the spam filter would not be fooled by some synonym changes. So if the spammer is changing some words by some synonym, it should not change the output. It should not change the classification of the classifier of spam filter. Also, in terms of privacy, well, in that case, we don't want the email content to not be leaked from the trained model. So, say that we deployed our model, and if the model is leaked, or if it's accessible to our user, we don't want user to be able to read the content of other emails of other users. So at this step in the goal definition, what can be good to do is a cost-benefit analysis. So you can learn more on Wikipedia. We don't have really time to go into more detail on how to conduct such a thing, but I think it's a quite good framework to think about it. So the general idea is that you need to analyze what is the benefit of deploying such a model, doing such a task in an automated way using machine learning, and to compare it with the cost. So you can compare it into monetary value. For example, if you are in the industry, what is the benefit? What is the money that will be bring by doing such a model as a benefit? What money will be generated? And the reverse, what money would it cost me to invest? You can also think about that in terms of times. If you are in academia, for example, what is the time that I will, what will be the benefit of that I will gain from that? But in comparison, what will be the cost? So to estimate the cost, we already saw the three types of cost, but you have to consider some things. So first, you have to consider the difficulty of the problem. If there are existing libraries that allow you to train your model, for example, if you have some existing libraries that it will be a lot easier to train the model and to find a good model than if you have to build it by hand. So it's one of the questions that you have to ask. Also, do I need a lot of computation to train and serve the model? This is basically the complexity of the problem. If your model is just spam filtering, it's not an easy task, but it's not very complicated. If you want, on the other hand, to detect, to do some, as we have said, some detector of people for autonomous driving, for self-driving cars, it will be a problem that is much more difficult. Also, you have to consider the cost of data, because having some data, if you want to generate some data, is costly. So can the data be generated automatically? If it's such a case, it will be probably a lot cheaper to gather some data. Another question is the cost of manual annotation. If you have to label your data, what is the cost associated to it? So you can think that if you have to label images and to say if it's a cat or a dog, it's not the same cost as if you have to ask doctors and well-qualified doctors to label X-ray scans. So because this is one of the application of machine learning is to in the medical imaging is to classify X-ray scan. So you scan a bone, you have an image with X-ray of a bone, and you want to know, for example, if the bone is broken, or you can have different type of application. But this is the idea. If you have to pay a lot of doctors to label thousands and thousands and thousands of images, it will be a lot more costly than if you have to do some more simple task. Also, you need to think about how many examples do you need, because and this is related to the complexity of the problem. If you have a very complex task, you will need a lot of data. If you have a simple task, you will need less data, and it will be probably cheaper. Also, one thing to have in mind is the accuracy that you need, because how costly. So the first question is, how costly is each wrong prediction? We already talked about that, but if each wrong prediction is very costly, then you have to think to take that into account when you estimate the cost. Also think again of the spam example that we saw is that the specificity and the recall, the specificity and the recall were not problematic in the same way. Also, something to have in mind is what is the lowest accuracy level below which the model is impractical. So if you need, this is kind of the unacceptable behavior in terms of performance that we have see, and it's the idea, what is the minimum level of accuracy that I need, because if my model is too bad, it will not be useful. And one thing to keep in mind is that if you need good performances, the cost will be increasingly exponentially increase. The cost will exponentially increase with the accuracy. So here is just figures that is representing the idea. Is that if you need an accuracy of 80%, something like that, it will be not too costly. And if you want to increase the accuracy, at the beginning it will not cost you a lot, but the cost to go from 99% to 99.9% is very high, and it's a lot higher than going from 80% to 90%. So the cost will be, as you will increase the accuracy, the cost will be higher and higher when you want to increase the accuracy by the same amount. Okay, so now let's review the next point, that is data collection and data preparation. So this is closer to what you will do, and you will do that a lot when if you are either in a big company or in a small one. This is really, generally it takes a lot of time. So data collection and preparation, generally a student doesn't realize that it takes a lot of time. When you are in the industry, you really generally spend 80% of your time building the data set and only 20% playing with it. This is generally surprising for students because they expect that, the data set is generally easy to have. You spend 20% to have it, to clean it and to do some stuff with it, and then you can play with it and do the funny stuff. But unfortunately, in the industry, generally, it's really costly, and you spend a lot of time having access to the data, cleaning it, and doing all the process that we will see. Because the data are not so clean and it's generally difficult to access and not in the shape that we want, etc. So yeah, if I can give you an advice, is that if you go to the industry, really consider and expect to spend a lot of time in the data preparation part. Okay, so the different step here that we want to do when we prepare the data is we want to first to ask, is there existing data? So if there is existing data, then you have to access to the data. Maybe it will involve some negotiation, some legal negotiation to access it, because it may be some restricted data. It may need some paperwork, some form of payment if you have to pay and argue with the prices. Also, sometimes you need anonymization, so you need technique to anonymize the data so that the data are not breached, are still confidential. So there is different type of anonymization. We don't have time to go into more detail, but sometimes it's just removing the ID or removing the name of the people. But be aware that generally it's not sufficient. And if you have, you can easily, it was shown by in academia with some scientific publications, and generally it's easy to recover people, to know people, even if you remove their name, for example. So this is basically because you in some data you have some information about people and some features, and generally you are able to make some unique match between people, between data sets, and uniquely identify people that way. So maybe anonymizing data is generally not as easy as removing some personal information like the birth date, the name, etc. So sometimes you have to spend some time to add some amount of noise in the data, because let's say that you take the exact age of people. It may be you may have with other features, you may have unique combinations that allow people to de-anonymize them. So if you add some noises, so let's say that you had sometimes you had 1, 2, 3 or more, or 20 or 100 days in the age of people. Well, maybe you can ensure some anonymization that way. If you have some existing data, you have to spend some time also to accessing the database, if there is database, to doing some transformation of format. If you have some data that is sent into different format, it can be merging dataset too, if you have to compute to merge a different source of data, etc. If you don't have existing data and you want to create a dataset, it's really you have to be able you have to understand that it may be very long. So I put a warning sign here because it can be really costly and really long to do that. But if you want to do so, you have to think of the way that we will collect some data. So you can use some scraping for that. You can scrap the web for that, for example, if it's possible. Scraping takes also a lot of time because generally websites are not well designed, and it can takes a lot of time. There is generally a lot of errors inside the data, and you need to change the way you scrap. You need to relaunch again your scraper, and things like that. So it can take a lot of time to scrape. And don't think that don't underestimate the time that you will spend on scraping. If you collect some data, you can also use some statistical sampling. So we will not go into detail here, but it's basically the idea about observing only a small amount of people, a small sample inside the population. Remember, in the second video, we saw the idea that to measure the height of Luxembourg peoples, how much meter each people in Luxembourg is measure the height of people, we may not need the entire population, the entire Luxembourgish people. We may only need a small sample, maybe only 10 or 5% of people will be enough to give us a good idea of what is the average of the height of Luxembourgish people. So yeah, you can use, there is a whole theory of statistical sampling to help you know in that way what is the kind of confidence that you can have when you do some sampling. So when you only observe a small percent of the entire population that you are interested in. You can also build some survey together to collect some data. So in that way, you have to think about the way you do some survey sampling, and also way you design survey. So you have a lot of. This is an entire field, so I'm not able to go into detail either. But you have also, as we said, to think about how you will label the data with different costs associating to it. And you have to think about all the process that is associated with collecting the data. Maybe you will need to deploy a platform and to present to user photos of images of cats and dogs and this type of things. And maybe you need to present them twice in order to collect some data. So maybe you know that, for example, that Google, when you are filling a CAPTCHA, you are working for free for Google, kind of, because generally they know some answers. So when you are asked to know where is a car inside the images and to click on the images that have a car, or when you have some stop sign and you need to click on the stop sign. Well, Google knows some answer to know if you responded well to the CAPTCHA, but for some images they don't know, and they just get inputs from people, and they submit it multiple times to ensure that they have consistent data with that. Okay, so you have to think about the way that you need to label data. Another step then is to clean data. So this is generally a tedious step and not really fun, but it's necessary. So you have to think of, for each feature, what is the domain validity, what is the expected range of value that it can take. So you have to think of that really for each feature. It will be different for each feature. It can be different for each feature. So yeah, keep in mind domain validity in that, because especially if you have user inputs, it may be sometimes you will have some crap in your data, basically, if you can allow me the word. Because for example, if you ask the age of user, well, probably you will have some users that will put fake age, and that will be 100 or 200 years old, or things like that. So you have to think to clean your data in order to use your data. So you can think also of removing outliers. So if you have some data that are very far away from the other, it's a good thing to remove outliers, because it can affect a lot the training part of your machine learning model. So think of removing outlier. You have some different algorithm to detect outlier, but generally it's good to analyze them. So you can plot the example, your data, you do some plots, and to see if some examples are really far away from the other. You can also look at some descriptive statistics. So for example, you can look at the maximum value. If you see that the maximum value is very far away from the center, from the expected, what you can expect from from this feature, maybe it's a good thing to remove some examples that are outlier and that will that will make the training part of your model hard. Okay. Think also of errors, because sometimes you have errors in the data. So just things that are coded in a strange way, or things that, well, erroneous data. So think of checking that too. Maybe you have duplicated data. So think of checking if you have that too, because it can be bad for learning from that. And yeah, also if you have some old data, some expired data, it will be good probably to remove them, because if it's not valid anymore, well, probably it will harm the training phase of your model. Another step of data collection and preparation can be data augmentation. So this is optional, but data augmentation is the idea that you, in some way, you can augment your data. You can have more data from the data that you have. So one application, classical application of data augmentation is in computer vision. In image recognition, for example, if you have images of cats and dogs, it can improve your model if you also give the same images, but that are rotated a bit. So you randomly rotated in some ranges your images of cats and dogs, and it will help the model to understand that, well, if you rotate a bit of 10 degrees your image of a cat, well, it's still a cat, and so it can help. You can also do some image mirroring, so you mirror your image and you give it also as another example to your model in your training dataset. Some advice here. So these are really the advice that I give you from the industry and from working as a freelance data scientist. So the advice here is to think of reproducibility from the beginning. So here reproducibility is a fact that you are able to have the same result when you execute the same process. So here you might have extracted some data and think that for example, you will need to rerun the data extraction, because generally, even if you think, it happened to me, that you think that you will extract some data once and it will be done. So, but generally you will need to extract it again, because maybe you will need some other features, or maybe there is some errors on your data that you weren't aware of, or there is a lot of different reasons. It can be bugs. You can add more feature. You may need also to update your data, because if you have new data, you may need to update your data set. So really think that you will need to extract the same data again in the future. Another advice is to always check the raw data and the processed data. So if you process some data, if you do some things, take some examples, some specific examples, and check that what you have done is corresponding to the thing. So for example, if you let's say that if you only selected the emails that were not empty, if you are working on a spam filter, maybe check that the length of the content of the email is never 0, or if it's higher than 2 or 3 characters, for example, or something like that. So yeah, always check that and also check some examples. So you take some examples from your database, from your raw data, and check that it's corresponding well to the processed data. The idea here is that you don't trust only on your implementation for it to be valid, is to trust. Take some example to see that what you are expected correspond to what you have found. So this corresponds to a personal story, is that when I was working for a client, we had some different data, and I know that I was using the service of the client, so I know that I was in the dataset. I found, I searched for myself in the dataset, and I found that some features associated to myself were strange, because I know that I was using the services in some way that were not represented by the features. And then I searched for the source of the problem, and I saw that in some cases the features were not were double, so they were multiplied by 2, even if it was not expected. Like you expect, it was the number of people. So I know that I was it should be always 1 for me, and in the feature it was 2 in some specific cases. So I knew that way that the computations that we were doing were wrong, because the data were not clean and were multiplied by 2, even if we didn't know that. Okay, so don't trust your implementation and verify it. Also, an important thing is to keep backups of your data before processing them and after. So you can keep both datasets, not only one, because if you find that you have a bug in your processing script, well, then you have to be able to rerun it. Okay. Also, don't assume that your data is valid. I just gave you an example, but it's important to check that your data is good. So this includes checking some validity. So if you have postal code, for example, check that it's good. So another example from when I was a freelance is that we had the French postal code, and French postal code at the beginning starts with the region number, the sub-region number, the département in French, and these are number between 1 and 97. Okay, so here you have to check if it's really valid, because in that case we found that some people put 99 as a department, so it doesn't exist. So generally it corresponds to foreign country or things like that. But sometimes it's just that we had someone that that put some fake data and put 9999 and things like that. So check that. Also check the validity of age. So you can expect that people have an age between 0 and 120 or 110, for example. This is the validity domain. Also, make sure that you properly encode your missing values. So sometimes people encode missing value by putting -1 on 9 and you have to process it, and so that it's correspond to not a number, NaN, if depending on the language that you are using and the implementation. But generally, to have some data, you have some type that you have to use to encode missing data. So this is especially important, because if you have a continuous variable and you left this 999 as a missing data, well, when you will process it, what your model will see is that it's equal to 9999. The model will not be able to know that it corresponds to missing data. So really think always on how is encoded your missing values.